Okay students, in this video we are going to see about how to work with Multisim software. So when you install the Multisim software, you will get this Multisim icon on your desktop. If you double click on it, the user interface will be open. In this work area, we have to place all the components and have to connect them. So in this components toolbar, we can place sources, basic components, diodes, transistors and analog devices, etc. Now I am going to construct one CE amplifier. In order to construct a CE amplifier, I need one transistor and remaining components like resistors and capacitors. So the main component is the transistor. That's why I'm going to click on place transistor. So in this we have to select whether it is a NPN type of transistor or PNP type of transistor. I'm going to take the NPN type of transistor with the number 2N2369. We can select the number and type of the transistor in this window. After this, we have to click on OK button so that we can place the transistor in our workspace. So now, in order to place the resistors, I'm going to click on the place basic. Here we can take the standard resistor values. Once if you place the standard resistance value, we cannot modify. If you take a virtual resistor, we can modify the value further also. So that I am going to take a virtual resistor. So going to the basic virtual and then resistor virtual. I am going to select it. So basic virtual, resistor virtual and then clicking on OK button. So I am going to place this resistor here. So I need to rotate this resistor in clockwise. That's why just click on the resistor, right click and then click on 90 degrees clockwise. Now I am going to place the resistor in this place. I need one more resistor, so that what I am going to do is just I am going to copy this resistor and then pasting here. Okay, here, and I need the two more resistors for biasing purpose. Now I am going to change these resistor values by just double click on that resistor. We can able to change the value. So this biasing resistor value is 100 kilo ohms and this biasing resistor value is 10 kilo ohms. I'm just taking like that. And then this collector resistance value is 4.7 kilo ohms and this emitter resistance value is 1 kilo ohm like as this. Okay. So next I need one more resistor at the input side. We need some capacitors. One is at the input side, another one is at the output side, and one is the emitter bypass capacitor. In order to place the capacitors, we have to go to the place basic and select the capacitor virtual and then click on OK. I am going to place this capacitor here. Thereafter, I need one more capacitor, so that I am copying this and pasting here. This is the output capacitor now. I need one more capacitor at the emitter section, which is called emitter bypass capacitor, and rotating that also. And these capacitor values I am going to change like the 10 microfarads. Just double clicking and then entering the value here. So all capacitor values are same and the input resistance value is 1 kilo ohm. Now I am going to interconnect these components. In order to do this, just place your mouse at the end of each component and then click. Then you can get the wire and then take this wire up to the next component and then click. So the wire has been joined. Now I am going to connect this resistor with the emitter resistor. So many students do mistake here. Directly they will connect the base to the capacitor without giving a node here. So please avoid this mistake. In order to avoid that mistake, just connect the base to wire first, then you can connect this capacitor to this node. So the basic circuit is over. Now we have to give the supply voltages and the oscillator connections. So in order to place signal source, we have to go to place source section. This one. So in this place source section, I am going for the signal voltage and AC voltage. So just click on OK. So here I am going to place this AC signal source and then connecting that to the input resistor. And this pin is going to be grounded. Next, I want to connect the VCC source, so that I am going to place source, then power source, and then select VCC. OK. So I am just placing the VCC here and then connecting that VCC to this wire. Next, I am going to place the ground. So same, place source, then select the ground, not the digital ground, ground, and then place here and connect this ground to your circuit. Now we have to connect. So the fourth one will be the oscilloscope. So the circuit is over. Now I am going to run the circuit. In order to run the circuit, this switch we have to turn on. And then I am going to click on the oscillator section. Now the voltage is very low here. That's why I am decreasing the y-axis scale. So now you can see the circuit is working properly and we are getting amplified output. We can pause the simulation by just tapping on this pause button. Then you can able to measure the voltage. You can take the cursors and then place at the positive and negative peaks of the waveform. Okay, so when we place at the positive and negative peaks of the waveform, you can see the time difference and the voltage difference. You have to place the cursors. One is at the positive peak, another one is at a negative peak. So when you place like this, here the voltage is 452 millivolts and our input voltage is only 5 millivolts. So now we are going to see about the board plot for this, which is called AC analysis. In order to do this, we have to turn off the simulation first and go to simulate menu and then go to analysis and select AC analysis. So here we have to select the input frequency range from 1 Hz to, suppose I am taking 100 megahertz. So my graph is from 1 Hz to 100 megahertz range. Sweep type should be decade and the number of points per decade should be 10 and the scale should be decibel scale. Okay, so here it is okay. Next go to the output section. In this output section, by default the y1 will be the output. It will take like that, but we have to remove that and we have to select the our output wire. Here you can see output wire number is 2. So that I am going to add the second wire to the output. So that's why selecting the 2 and then clicking on add button. Then we are going to click on the simulate button. So this is the simulated output. In this simulated output, one is the magnitude graph, another one is the phase graph. I'm going to see only magnitude analysis here. So that's why I'm just cut the phase plot. So in this magnitude plot, I'm going to calculate the maximum gain and minus 3 dB gains. So that I'm going to select show hide cursors button. I got the two cursors. In these cursors, the blue color one is the number 1 and yellow color one is the number 2. So here the values representing for the 1 is x1 and y1. x1 is the frequency, y1 is the gain in decibels or magnitude in decibels, and the values corresponding to yellow color line is x2 and y2. So here we got the maximum gain, this one. So just I am placing the line 1 on the maximum gain. So here you can see the y1, which is a magnitude, which is 33.4, will be the maximum magnitude. So I have to place the cursor at minus 3 dB. So that what I am going to do is just right clicking on this blue color line, set y value to the left side, which is 30.435, and then clicking on OK. So now you can see the y1 value is set as 30.41. Now I'm going to set this yellow color line to the minus 3 dB at the right side. So that's why I'm going to select this white yellow color line and then right clicking on it, set y value to the right side and entering the value like 30.4105. Now you can see the y2 value is set to 30.4105. Okay, so here minus 3 dB values has been set. Frequencies corresponding to the number 1 line will be the lower cutoff frequency, which is 195 Hz, and frequency corresponding to the yellow color line, which is x2, that is 1.18 megahertz, will be the higher cutoff frequency for this amplifier. Therefore, the bandwidth of the amplifier will be the higher cutoff frequency minus lower cutoff frequency, which is represented like a dx here. Okay, dx is equal to 1.18 megahertz. This will be the bandwidth of our CE amplifier. So, if you are working with the oscillators, like I will show you one oscillator, which is a Colpitts oscillator ready with me. So here it was open, and for this type of oscillator circuits, after constructing the circuit, we just need to turn on the simulation switch and then double click on the oscilloscope and wait for some time. So here you can observe the voltage is getting increased. So and these voltage will increases gradually and will become constant at some point. So we have to wait until the magnitude is becoming constant. So now the amplitude is constant. In this time we have to press the pause simulation button, then take the cursors and place it. One is at a positive peak, another one is at a negative peak, so that you will get the maximum voltage, which is 8.93 volts. And also we can calculate the frequency from the difference of the time. So we have to place this at the complete cycle from one positive half cycle to another positive half cycle, or one negative half cycle to another negative half cycle, or one complete cycle. So which is 663 microseconds. If you convert this time into the frequency by using 1 by t is equal to f, we can get the frequency. I hope this video is useful to you. So thank you for watching.
I'm just stressed out. I'm trying to balance all that comes with being a content creator, from managing my